So today's video is on the link reaction. So the link reaction is the second stage of respiration, and you will need to go see the previous video for the first stage of respiration, which is glycolysis. So the link reaction is the second stage of respiration that we're looking at. So it's glycolysis, then the link reaction. So if you haven't looked at glycolysis, I really recommend going to see the previous video, because otherwise some of this will not make sense. So jumping straight into the process of the link reaction, our first stage is active transport. So during glycolysis, the first stage of respiration, it produces pyruvate. So pyruvate, the product from glycolysis, is actively transported into the matrix of the mitochondria. So glycolysis takes place in the cytoplasm. So in the cytoplasm, we now have pyruvate as our product, and this pyruvate needs to be actively transported through the outer membrane, the intermembrane space, and the inner membrane into the matrix of the mitochondria. So the matrix is the solution filling the mitochondria with all the enzymes, ribosomes, proteins required for all of the processes the mitochondria needs to carry out. So we want to get our pyruvate into here actively. The second stage of the link reaction is oxidation. So our pyruvate is now in our matrix of our mitochondria. So the pyruvate in the matrix is now oxidized. So oxidation is the loss of hydrogen. So our pyruvate that has now been actively transported into our matrix loses hydrogen. And this pyruvate is converted into acetate. So it's converted from this 3-carbon molecule into a 2-carbon molecule, which is acetate. And during this process of converting pyruvate into acetate, carbon dioxide is released. So you can see that we have 3 carbons here in our pyruvate and 2 in our acetate. So 1 carbon must have been lost, and this carbon is lost through carbon dioxide. And because our pyruvate was oxidized, and this means loss of hydrogen, these hydrogen atoms need to go somewhere. So when it releases 2 hydrogens, these are used to reduce NAD. So our NAD comes into our reaction, our NAD coenzyme, and this NAD is reduced using these 2 hydrogens into reduced NAD. And reduction is the gain of hydrogen. So our pyruvate loses our hydrogen, it is oxidized so that the hydrogen atoms can bind to the NAD to reduce it. And so NAD, just as a reminder, is a hydrogen carrier molecule, and it's also a coenzyme. The third stage of the link reaction is of coenzyme A. So we have our acetate, which is formed from our pyruvate. So our 2-carbon acetate now combines with coenzyme A. So a coenzyme, just as a reminder from the previous video, are molecules that some enzymes require to function. So NAD is an example of a coenzyme because some enzymes require this to function as a hydrogen carrier molecule. But so just for this, our acetate combines with coenzyme A. And this combination of acetate and coenzyme A forms our acetyl coenzyme A. So this is another 2-carbon compound. And this is our product from the link reaction. So our acetate and coenzyme A form our acetyl coenzyme A. So our overall link reaction can be formed into this equation. So our pyruvate from our glycolysis has been actively transported into our matrix. We have our NAD, because our NAD is introduced to the reaction to take away the hydrogens that are lost from our pyruvate. And we have our coenzyme A, which is used to combine with our acetate to form our overall product. So we have our pyruvate NAD and coenzyme A for our reactants. Then as our products, we have acetyl coenzyme A, and this is an abbreviation for coenzyme A. And because this is our overall product, we have our reduced NAD, from where our NAD has been reduced by gaining hydrogen, and we have our carbon dioxide, because when our pyruvate is converted into our acetate, a carbon is lost. However, this overall link reaction happens twice per glucose molecule, and this is because, as we saw in glycolysis, the first stage of respiration, one glucose molecule produces two pyruvate molecules. So per glucose molecule, the link reaction happens twice because it has to happen to both of the pyruvate molecules that the glucose produces. So technically, this is the overall link reaction for one glucose molecule. Each pyruvate molecule is being worked on. So as a quick summary table, our inputs and outputs, we have an input of two pyruvate molecules for our one glucose. So our glucose in glycolysis has been broken down into two pyruvate. So our two pyruvate molecules are being worked on. So we have an input of two pyruvate. We have two NAD because we have an NAD for each pyruvate to take in the hydrogen atoms that the pyruvate loses. And we have two coenzyme A because both of the acetates produced needs to combine with the coenzyme A. And our overall output is two carbon dioxide because each pyruvate loses one. And we have two reduced NAD because both of our NAD receive hydrogen, so become reduced. And we have two acetyl coenzyme A because both of our pyruvate are eventually converted into acetyl coenzyme A.